All right, we're back. We are on page 4 of notes 12 of Calc C. We're talking about arc length, and let's get going because this is a very similar problem. This actually looks almost identical to one of the ones that we just did. Determine the behavior of the curve at x equals pi over 2. All right, so determine is it like a maximum, a minimum, neither, increasing concave up, increasing whatever. Let's find the derivative and see what it tells us. So dy dx is going to be 1 over sine. The derivative sign is cosine. So cosine, sine, so cotan. Oh, good. Now we get to remember cotan. So the tangent of pi over 2 is undefined. So cotan of pi over 2 is 0. And then, do I want to first derivative test? Second derivative? I'm going to do second derivative test. So second derivative of this is negative cosecant squared. Okay, so dy dx at x equals pi over 2 is 0. And that's, so it was because the tangent is undefined, so the reciprocal of undefined is 0. And then the second derivative at x equals pi over 2 is going to be the sine of pi over 2 is 1, so negative 1. Okay, so since dy dx equals 0, the second derivative is less than 0, y equals f of x as a relative, so that's, concave down, and this relative maximum at x equals pi over 2. There you go. All right, write an integral representing the length of the curve y equals f of x. Well, we already found the derivative, thankfully. So the derivative is, what did I do to my brightness? Turn this up. Okay. So this is dy dx, right? So we're going to do the integral pi over 6 to 5 pi over 6 of the square root of 1 plus the derivative squared, so cotan squared of x dx, which, so that's an integral. And then this by property, what are we doing? I have like such a headache. I had meetings from I don't know, from 8 until like 2:45 basically today, and my brain is fried. So I don't remember what I was doing before I started telling you that, but 1 plus cotan squared is equal to cosecant squared. Cosecant, I don't know, if sine is positive on this interval, so cosecant is positive on this interval. Is sine positive on this interval or sine negative on this interval? Pi over 6 to 5 pi over 6. Sine's positive. Jeez. Okay. Get this. Now remember, there's a trick for this integral. You multiply by, so if it was secant, you would multiply by secant plus tan over secant plus tan. Here you do cosecant plus cotan. So I'll show you the work because it's not exactly the same, but it's basically exactly the same. So you're going to do cosecant multiply by cos. You could do negative over negative. I don't know. Well, yeah, why not? Nah. I'm not going to do that because I have a headache, and I don't know if I'll successfully get through a slightly different, even though it's just like negative signs. All right, so what does this give us? I wish I'd made this indefinite, but I didn't. So cosecant squared, should be cosecant cotan. Sometimes I say co, and I'm like, yep, that's a CO, which it is, but you don't write it. We're on it, hopefully. All right, so the derivative of cosecant is negative cosecant cotan, but there's no negative sign. And then the derivative of cotan is negative cosecant squared, but there's no negative sign. So we have to put in a negative, which is what I was planning on doing at the beginning, but then chickened out on. So this whole thing will be the negative natural log of the absolute value of cosecant plus cotan from, oh my God, pi over 6 to 5 pi over 6 I don't know why I just decided to look and see what's left in this. It's like, we're almost done. All right, so this is negative natural log of, all right, the sine of 5 pi over 6 is 1/2, so the cosecant is 2. The cotangent, so the tangent of pi over 6 is radical 3 over 3, so the cotangent is radical 3, but we're in quadrant 2, so negative, so minus root 3. So 2 minus root 3 is positive, so you can drop the absolute values. Minus negative natural log of. I feel like this can be the same discussion. 2 both them plus radical 3, I guess. 2 plus radical 3 is definitely positive. So here we get negative natural log of 2 minus radical 3 plus natural log of 2 plus radical 3. And so, like, what might someone do with this? Well, you can rearrange it, you know, and have the positive minus the other thing, and then subtraction becomes division. So this will be the natural log of 2 plus root 3 over 2 minus root 3. And then I think if we check it on the calculator's going to rationalize that. So what is that going to entail? That would be like multiplying the top and the bottom by the conjugate of the bottom, which I don't want to do. Again, I'm going to pretend that's because of my headache, which it may very well be. Do we want to check this? Let's check it. So remember, the calculator has arc length built in. So also, I don't have the calculator open. So let's try again. All right, here we go. So I'm going to use the built-in arc length thing, which is arc length. There we go, arc length. Natural log of sine of x. X is a variable, and we're going pi over 6 to 5 pi over 6. Okay, so what if I had rationalized? What is 2 plus the square root of 3 over 2 minus the square? Oh, you know what? Yeah, all right. I apologize for my laziness. This we should have been able to do. Here, let's go back, and I'll just like do it I'll do it by hand. We're doing it by hand. So it's kind of actually an interesting one. Now that I see the answer, if I multiply the top and the bottom by the conjugate, right? So that's going to give me the natural log of the quantity 2 plus radical 3 squared over. Then when you multiply by the conjugate, you just get like a squared minus b squared, so you get 4 minus 3. And then, so that's 1, obviously, and then exponents become coefficients. So it's actually easier by hand to show that this is equivalent. There you go. All right, let's just knock, I think we can knock these out. I don't really know why this one is here. Unrelated, but still evaluate. Like, what does that look like? It looks like I'm gonna have to complete the square there. Also, I don't know why I'm looking ahead. The arc length of a curve y equals f of x passing through 2, negative 3 is given by the definite integral. Find f of x. Cool. All right. So this is like, this is f prime of x squared, right? So f prime of x should be 2x cubed. So if x is 2, no, passing through, okay, I don't even know. Passing through, what are we doing? I don't know. All right, so then f of x should be 1/2 x to the 4th plus c. And then using this, we would get that negative 3 equals 1/2 of 2 to the 4th is 16 plus c, so that's 8. So c is negative 11. So f of x, like, could it be negative 2x cubed? Because if you square that, that would work. I think that would also work. Like, I think that there are 2 possible answers to this, one of which I'm not going to find. Or should I find it? I should probably find it. All right, so let's say I'll do it like really tiny over here, perhaps. So if f prime of x, it's negative 2x cubed, then f of x is negative 1/2 x to the 4th plus c. And then using the givens, negative 3 is negative 8 plus c. So c is 5. F of x is negative 1/2 x to the 4th, comma, plus 5. I think either of these work. So there's that. And I don't think there's any reason not to do both. All right. So let's see. Just like soon. Okay. That last problem is very common type of arc length. Keys. Look. Yes. All that's good. All right. We're going to complete the square on this because I don't know what else to do. So I'm going to say this is the integral of 1. This is kind of cool. How I got that to happen. So I'm going to take out negative 9 because I don't like to complete the square with a negative leading coefficient. And it'll be minus 4/3 x. Okay. And then the dx, I don't really like putting dx up here anymore. I used to, but then, I don't know, I came around. All right, so if I divide by 2, I get negative 2/2, and if I square it, I get 4/9 plus 4/9. What? Plus 4/9 minus 4/9. And then keep going here. Keeping that negative 9 out there for now, because I think I'm going to be able to do something with it. So the first 3 should be a perfect square. It's x minus 2/3 squared. And then if I distribute the negative 9, I get plus 4. Okay. This is not like an impossible integral, but it's not the most fun you can have while doing an integral. 1 over, we're rearranging, and I think I'm going to take 4 out of the radical, so I end up with 1/2. So it'll be 1, and then I get minus 9x minus 2/3 squared, oh my god, over 4. This is definitely arcsine. Okay, so if I say that u is 3x minus 2/3 over 2, then that is u squared. So then du is 3/2 dx, so 2/3. I'm gonna actually do the substitution. When you're not feeling it, you do the substitution, right? So 2/3 du over the square root of 1 minus u squared is 1/3 arcsine of u, which is, I'm going to distribute 3x minus 2 over 2 plus c. Let's check that one. I think it's right, but like, who knows? And then obviously, I'm just assuming that this is a crazy long video. I don't really know. Integral of, I feel like it must be, because I think it's the first video that is this like 20 minutes long? I don't know. Integral 1 over square root of 12x minus 9x squared, comma x, comma nothing. 1/3, yeah, feels good. All right, we got it. Nice. So done with that page. Probably definitely should have stopped halfway through, but I didn't. And so we all got to enjoy that ride. All right, so page 4 done. I will be back in the next video, do some more, and I will see you there.